So as Louis said, I'm here from the Catalyst Center, which is traditionally the tech transfer office or the business development office at the University of Guelph. I'm going to talk a little bit more in a sort of brass tacks way about how the university actually engages with industry and how we carry out some of the inventions that come out of the university. So University of Guelph was founded, there are three founding colleges. One is the Ontario Agricultural College, and it was actually founded in the late 1800s, 1870s, and then the Ontario Veterinary College, which was founded in the 1860s. So there are, there's 300 years of history between our vet college and our agricultural college, but it really speaks to Guelph's passion and background strength in these areas. And also our third founding college was a home economics women's studies department. So those three colleges merged in 1964 to create the University of Guelph. So since then, we've now evolved to have 7 colleges, 33 departments, 800 staff. So it's now the breadth and depth of what it is that Guelph studies is significant. As such, we're noted as one of Canada's top comprehensive universities most years in Maclean's magazine. And for our partners from the Netherlands, this is an annual ranking that comes out in a popular magazine. But I can tell you most parents who are sending kids to university run out to buy it and say, you're going to go here because it's ranked #1. So University of Guelph does well in the comprehensive ranking. We are also noted as Canada's food university, and that's by the Globe and Mail, which is one of our 2 national newspapers. And so seen as Canada's food university, and I think the history of coming from our agricultural background really speaks to why that accolade has been given to Guelph. So the Better Planet Project is the current capital fundraising campaign that's being run by the president. And what he's identified are 4 pillars of research strength at the University of Guelph. And again, they speak to exactly what it is we're here to talk about today. Food being primarily, I would say, what Guelph is known for, communities, environment, as well as human and animal health. Now, our most recent accolade, I'm very proud of this accolade. This just came out a couple of weeks ago. And University of Guelph has been ranked Canada's most inventive university. And I think the word invention is very important here. And in defining, Louise has asked us to define innovation. I think invention is one step. We talked about the step in the cycle this morning. I think invention is one step in that cycle. But University of Guelph does the inventive step very well. The remaining cycle, which is about, I agree, getting products, processes, and services onto the market, is what we turn to our industry partners to help us with so that we can do that more collaboratively. So why are we ranked Canada's most inventive university? 2 measures. One is that we see the most disclosures. So when a new technology is created by a professor, they say, Eureka, I've got something new. They can choose to disclose that to the university and then through our office, and we carry that forward to do the patent protection and license to a partner. So we see more disclosures per faculty by about 3 to 1 than any other university in the country, than the average rather, in the country. So about 1 in 6 of our professors actually make a disclosure. And you can see this is the pointer, right here. And the average is, where did I see it? Here, about 0.52. So the second important ranking is that we do it cheaper than anybody else. On average, the disclosures that we see net out to being about $1 million per disclosure. So $1 million of research money goes into the university per disclosure that we see in our office. And the national average is between $3 and $4 million. So we're not bad at that. Now, I would argue again, this comes right back to our agricultural history, the idea of extension that's been part of agriculture forever. And so it's part of the DNA of University of Guelph to say, the research we're doing, how do we apply this in society? So at the Catalyst Center, what do we do? This is sort of the operationalization of how we get our inventions to you. So traditionally, we are the Technology Transfer Office. So Technology Transfer is responsible for finding discoveries at the university, finding new innovations, going through the evaluation and patent process, so making sure that we're taking care of the rights of our researchers, and then finding receptors. So we have solutions, and we go to find the problems that need to be met in society. So this is changing, though, I would say, across the country. And what's new at University of Guelph is that we're also looking at it from the other way around. So traditionally, it's been a push to get technology out of the university. But what we're looking at now through our new industry liaison program, it was implemented with one industry liaison officer in 2012, and we now have 3 full-time officers. It's our responsibility to act on behalf of industry, to understand what are your problems, what are the challenges, what's keeping you up at night, and then to link you with a specific expertise at the university so that we can help you solve those problems. And we've seen trends in government funding in the last number of years that's really pushing industry-led innovations. And so for us to go out and understand what are the challenges you're facing and how can we leverage the expertise we have at the university. It was noted this morning, I think Dr. Art Hill, is Dr. Hill here? Here he is, who's the chair of the food department at Food Science Department at University of Guelph, said, you know, we can't get Tri-Council funding, our base research funding, we can't access it anymore if we don't have industry partners. And so this role of industry liaison, where we're saying, researchers, if you want to access research funding, we need to be answering what's going on in industry. We need to be answering the challenges of industry. And so this has become a really important hallmark of what it is that University of Guelph does and how we're engaging with industry partners. So we also do a limited bit of entrepreneurship. If we have professors or students who want to start new companies, we help with that a little bit, as well as knowledge mobilization. So understanding if there's not really a technology that we're looking to transfer, but there's great research knowledge that could change an industry or make an industry more efficient, it's up to us to help translate that knowledge to hands that need it. So who do we involve here? I think there's a really unique relationship that is important to mention with University of Guelph. OMAFRA, which is the Ontario Ministry of Agriculture, Food and Rural Affairs, has had a very important partnership with University of Guelph for years and years. And through that partnership, there's base funding that's come to the university that's helped us establish a culture of research that's about extension, that's about translating the information that we do. And the applied research, it's allowed researchers to foster areas of expertise that are needed in our food development industries. The government is recognizing then what's important to our industry and to our economy, and they come back and help us direct our research so that we're answering those challenges. So I want to point out, these are some of the important players. This is not, the positions aren't static. And so, you know, sometimes we get funding that go directly to researchers for baseline research. Sometimes our industry liaison work with industry partners to understand what are their challenges, and that's what directs research. One of the most important things that the industry liaison group does is to leverage government funding. So I mentioned government is really looking to industry-led research. I'm going to talk in a few minutes about some of the programs that we're able to use to leverage funding when industry comes to us with research and development dollars. The hope then, you know, in the perfect cycle, we've developed some really interesting intellectual property. We've managed to patent it, and then our tech transfer group can then make sure that that's transferred out to market to be applied and maximized. Quickly, this is our process for technology transfer. So this is the process we go through after we get a disclosure and about how we move things to market as quickly as we can. I'm not going to go through that process, but what I am going to say is these are some of the products that have come out of University of Guelph, these are solutions we've created that have made it to market. So this is a genetically modified pig called the EnviroPig. It poops out 30 to 60% less phosphorus, which is nice, but it's most interesting when you consider in hog farming operations, the phosphorus runoff lands in waterways, promotes algae bloom, and kills off the plant and animal life. So this is a significant environmental problem. We talked about regulatory barriers, so genetically modified animals are not regulated to be consumed by humans yet. So this is, you know, it's a very interesting technology where we've got 9 generations of stability in this animal, but it's not something that industry or that consumers are ready to look at yet. So if you know anybody who wants an EnviroPig, you can come talk to us.
Is it on the market, really, a GMO pig?
Sure. Well, I mean, the science is available. So we've got, we have regulatory applications in play. We've got patents and trademarks on this pig. And so, you know, if somebody's interested in playing with the technology, we'd be happy to license it. There are a whole host of ethical and religious and political debates. Right, and you know that's been an interesting learning in this is that it's sometimes science isn't. It's not just the science. It's not just the chemistry or the genetics that we have to consider. There are all sorts of considerations as part of the responsibility of the university. Today, I'm just pointing out some of the breadth of research that's been created. Dairy oat milk. This is a DHA enhanced milk. And this, I think, is a phenomenal story. This has captured in the last, it's been on the market, say 5 years, captured 5% of the fluid milk market in Ontario. That's significant. And now it's moved into cheese strings, which are disgusting little cheese pieces you can pull apart and feed to your kids. It's great for their brains. Feta cheese. So this has had a phenomenal effect. And you talk about, looking toward healthier products, some of the trends that you discussed earlier. This fills that need. It's also commanding a lot more money. A regular 4-liter bag of milk is about $5.50. This is selling for about $7.50, and it's still captured 5% on the market. So, one of the questions I had for you is, are consumers willing to pay more? I guess, in some cases, certainly. This is a pre-response vaccine. It's a vaccine for shipping fever in cattle. Yukon Gold potatoes. Did you know that was a variety that was developed at University of Guelph? Millennium asparagus, which is one of the most marketed varieties of asparagus on the market, was created at University of Guelph. Omega-3 eggs as well. This is a very cool technology. It's a living wall. So if you can envision that this whole wall would be covered with beautiful plants, and it cleans the air, so it's got sort of microbes and lovely plants that filter the air. So you can see there's a wide variety of research that's done at the university that's been transferred already. Any questions about any of these? So I'm showing you all, that's all the nice stuff. Now the grim reality is, truly, if you're looking at the return on investment of research dollars that go into a university, it stinks, actually. Last year in Canada, this is a representation of about 37 universities that have reported on a national report. So about $5.4 billion research dollars went into universities. Of that, there were about 1,800 disclosures across the country, representing about $3.1 million, or $3 million for one disclosure. Of those, about 10% of patents were issued. So in Canada, there were 181 patents issued through the university system last year. And what did that net? That yielded 1.2% of the $5.4 billion in royalty revenue. So about $66 million was returned to universities, inventors, because of the tech transfer deals. So not a great return. However, I think that I'm going to tell a story in a few minutes about, for instance, the development of an industry around soybeans. So for the university, if this was one of our primary goals that we were measuring, I'd say we're not doing a very good job of it. It's not really a primary goal of university, though. We're here to create new knowledge, to educate our students, and to transfer that knowledge into society for use. But this is one manner in which we do that. It's not our end goal. But the impact of those technologies when they get into society's hands is really valuable and important. And there's a case study I'm going to show in a couple of minutes to demonstrate that. So while these numbers don't look good, when my bosses say, Erin, are you going to be revenue generating? I say, no, I'll buy you a lottery ticket, because we probably have the same, it's about the same chance. Thank you, probability. Thank you. It's late in the day.
Erin.
Yes.
You're underestimating the return, though, because the R&D expenditure is a one-time expense. The
Yeah.
revenue stream from the royalties can go on for years.
Yes.
So there's a net present value.
Yeah. There's no question. I mean, this is it's not a perfect, it's a one point in time capture, which you're right, doesn't reflect, given the long sales cycle for any of these technologies. But it does demonstrate it's a tough game. I think it's a tough game, but the impact is significant. Those are the take-home messages. So I want to talk a bit about our industry. We've talked a bit about tech transfer, so things we create and transfer out. Now, what I really want to talk about is how are we engaging with industry in more creative ways to create more and better research opportunities that are applied. So the whole point of having an industry liaison project or program is about connecting industries with researchers and tools and labs that are available at universities. So how do we do that? It's important to consider this is our qualification practice. So when we meet with new industry partners, so Tyler Whale, if you could just wave. Tyler is one of our industry liaison officers. And so this is an important, we've talked about how do we qualify what's going to be a really good project, potentially between industry and academia, so we're not wasting anybody's time. So the things that we look for are, do we have the people who have the authority to make a decision? We talked today about the importance of having the decision makers in the room at any given time. So you can talk about innovation, but if the CEO is not committed to it, then it's sort of a lost cause, so it's wasted breath. Does company have cash to put in? And if there's not a little bit of cash from company side, if there's no skin in the game, we've got nothing to leverage. So again, it's a dead deal. Is the timing right? So a big part of what our role is to be a translator between industry and the needs of industry. And when industry says this is critical and imminent, I know that means tomorrow. In a researcher's world, that might mean next year sometime. So we have to be, it's important that we're translating between academics' expectations and industry's expectations. The identity of all of the partners that are relevant. So it may not, we talked about the importance of the successes that you saw when there were only 2 partners involved instead of 6 partners involved in a project. But it's important to consider, do 6 partners need to be involved? So we make sure we've got all the stakeholders who are pertinent around a table. Talking about the obstacles, and again, this is largely about communication and expectation management. Because really we are coming from 2 completely different worlds. We have valuable information and partnerships to add to each other, but you've got to be clear about what it is you're expecting from the other person. And then the last is, what is the need? What is the defined project? Who's the defined customer? And what is the outcome of this project going to be? So if we can answer all these questions clearly, we're in the running to get a project started. So I mentioned about leverage. So these are, I just want to go through some of the programs that we use to leverage money that industry brings in. So the first is the NSERC Engage program is a fantastic little program. And in fact, it doesn't require any inputs from industry off the bat. So we sort of call this the blind date. You get to hold hands with somebody before you have to commit to necking with them. So $25,000 government will put in. It's a quick 6-month directed problem solving. So if industry identifies a researcher they want to work with and can identify a problem that we think we can do in a relatively short period of time, easy to get $25,000. It's a great way to figure out, is the chemistry right? Is this an ongoing relationship that we think can build to something bigger and better? It's a great program. Ontario Centres of Excellence have a couple of projects. The technical problem solving, again, $25,000. Industry has to put a bit of skin in the game, $7,500. And again, about a 6-month program. So we can move beyond that into a collaborative research program, which can match up to $300,000. The match varies. It can be partly cash, partly in kind from industry, but it can be up to 2 years. And we sort of build one on the other. So we might start with an engage and then go to a technical problem solving and then move into a collaborative research. And so the risk for the company grows incrementally as trust grows, as the relationship grows. So these are nice programs to be using. FedDev, we've been using the Applied Research and Commercialization program. We've now created 24 projects with small and medium-sized enterprises in Southern Ontario through this program. And so 24 companies came to us with very specific objectives around goals for innovating, either creating, again, new processes, new services, or new products for their companies. And so 24 projects were able to benefit from these collaborations. And I mean, there were hundreds of them because this was spread out around 15 universities. But again, the message government is sending is we've got to find ways to be applying the research that's being created at universities. So this is where I want to share a little bit about the cost of innovation, but the value chain of innovation. So cost of innovation, what I've just gone through with the leverages, it can be quite minimal. You can get fairly good returns. This is a bit of a study about the OAC hemp soybean. This is a variety of soybean the first cross was made in around 1993 at the university. It was licensed. There was a number of tests were done and varieties were selected. It wasn't until about 2000, so 7 years later, that we managed to find an industry partner. There was no patent in this case. The IP has been left open because we've just done an exclusive license with CCAN. From there, we registered for sale, and sales started about 10 years later. So we're a life science university. Most of what we do is fairly long-term committed research. So the idea of building long-term relationships with our partners is really important. 10 years later, our first sale happened. 10 years after that, this is now a $10 million industry, crop industry in Ontario. So out of this $10 million that the crops returned last year, the university got $50,000 in royalty revenues. It's not going to make us rich. But there's $10 million contributed to the economy. Beyond that, there's another $850,000 in seed sales. So it's significant. The contribution of university research is significant, but it's not significant unless we have industry partners to operationalize it. So I can't stress enough the importance of we are one step in that innovation cycle, but together I think there are great things to be done. The ROI that we look for is certainly looser than in industry. I mean, certainly we're looking for impact, and that at any university we want to make sure the economic impact is important, but the social and environmental impact are also large considerations. For us in our office, our wins are products on the market. I love to see the products on the market that University of Guelph helped be part of generating. Royalty returns is important. Reimbursement, so sometimes it's just a matter of working with a company to say, you're going to help us with patent costs and we're going to do the work, and that's a decent return. Certainly increasing research budgets, because we're seeing tri-council funding, which is baseline research funding from government, is decreasing. So we're counting more on our industry-sponsored research. And then new jobs. I mean, any of those economic factors. Are there new jobs created? Are there new companies that have been created? Are our students being employed at the end of the day? IP management, this is the hot potato. So it's a hot potato for us every time. How do we deal with it? We deal with it up front. I mean, we've learned it's got to be one of the first things that we put on the table in conversation with industry. And our philosophy really, we've not moved as far as open innovation yet, but generally our first consideration is, how are you going to get this to market? How can we help you get it to market? And what are your needs? What are industry's needs? So if they need to own the IP up front, we'll make that work. We've got to consider the IP policy at the university, so our faculty own their own intellectual property. So if they choose not to work through our office at the university, academics are free, faculty are free to go and commercialize their research as they wish to. So they can work directly with industry, they can just publish and decide they're not interested in the commercialization process. If they come through our office though, then we act on their behalf to protect their interests, but also to maximize the value of that intellectual property. Certainly government contracts, you've got to abide by the rules and regulations if you're taking government funding. The government has their own demands around intellectual property. MTAs and NDAs are standard, but primarily this really should be at the top. I mean, industry benefit is what we're looking for, because again, if our endpoint is about products on the market, it's about enabling you to move this to market. So what's the mindset that's required to be innovative and for partnerships to foster between industry and academia? I think this is, I'm going to call back on I spent 10 years in medical device and biotechnology. So I worked for a couple of very innovative companies, and the messages that made the company innovative was the tone from the top. So we had CEOs who were risk tolerant, who allowed us to make mistakes. We got to stub our toes several times. It wasn't the end of the world. You weren't going to lose your job if you did something and it didn't quite work out. So I think that tone from the top is important. That idea of freedom to fail is important. The skunk works, allowing your staff to have a little bit of time to just go off and try new things, dream big, look at some blue sky thinking is important. And that's important around employee engagement. At the university, there's academic freedom, and so while some of the research is going to be directed, not all of it will be directed, and that's really important. Again, Art and I were talking this morning about, on the radio or in the paper you might have read, about the Canadian government is looking at how do we make faster tests for E. coli and Listeria. Well, if DNA hadn't been discovered, we wouldn't be considering these tests. Now, these future innovations, product innovations, wouldn't be happening without that fundamental baseline research. So, while we count heavily now, more heavily on our industry-sponsored partnerships, that baseline fundamental research still has to be a hallmark of a university. We cannot forget that. And so, the employee engagement is an important piece, and reward and recognition. Again, I'm looking to implement an innovation award at the University of Guelph, because I think it's important we look at within our researchers, if they're doing fantastically innovative, inventive things, we need to be recognizing that and the value of that. And then Louise asked us finally to speak about, is training and education important? Undoubtedly, without question. So we're seeing at the university there's a whole emergence of entrepreneurship. There's an entrepreneurial stream. We now have a residence that's dedicated to student entrepreneurs, and so they all go back and work 24 hours a day on their, 23 hours a day on their projects, and then study the other hour a day. We've got some regional innovation centers, and the collaboration between those centers and universities and other educational institutions is essential. These are our future innovators and innovators of the world, not inventors. The inventors, I think, still come from university primarily, but the innovators who are going to push these products or services to market need to be educated about it. There's education to be done about entrepreneurship. Certainly company internships, co-op programs are essential in terms of making sure that industry is getting what they want. And that's an important contribution of academia's part, is the highly qualified personnel that come out of universities and colleges. So working with industry also helps to inform the courses that are taught, so that we're delivering students who are trained with skills that you need in industry. And beyond that, I think Louise and I have been talking about exchange, the opportunity to exchange between college and university. So a more theoretical education with a practical education. But if we've now got students who come with both perspectives, man, wouldn't that be a boon for industry? So that is, that's all I have to say. What we hope to do is grow the value of great ideas. And I'm very much looking forward to hearing what my colleagues have to say about other institutions. So thank you.